Welcome back to another exciting episode of ScienceOverse Expert Panel. I'm your host, Anirban, and in this episode, we are thrilled to be joined by Dr. Akshay Patil, a scientist whose work sits at the dynamic interaction of remote sensing, geospatial analysis, and machine learning. So, without any further delay, let's get started. Welcome to the podcast, sir. Please introduce yourself.
Thank you, Anibal, for inviting me. So I'll give my brief introduction. I come from engineering background and currently working in industry, which is basically working with the geospatial solutions and using machine learning data science on images to create solutions. So I have a background in engineering, but I did some brief time for teaching also. And after my PhD, I joined academia, and since then I've been working with some startups in the USA. And currently, I'm working with the Japanese-based startup. More or less, it's the same work as a research uh, individual, and there I take care of all POCs, proof of concepts, developing solutions, and how to cater to the client. So that is what a brief about what I do.
Okay. So, sir, can you explain in layman terms what actually is geospatial analysis and remote sensing?
Yes, I could do that. So let me take a, take a step back and I'll explain you about the geospatial analytics. So in simple way, treat it as a combination of multiple data sources. So when you say geospatial analytics or GIS, it's nothing but how you can show the data in a spatial domain with some embedding, lat longs, correct? So basically Google Map. But to create that Google Map, you need many sources, rasters, vectors. And on top of that, any ground measurements, you build some analytics on top of that and display that information in an interactive way or a usable manner. You can create the report out of it. So at the core of this geospatial analytics right now is how you can handle the rasters, vectors, interact, and then intersections between these two data formats, TIFF and SHEF files, using any proprietary softwares like S3 and all. Or right now, it's an exciting space where the data science has taken over, correct? The chat GPT, GPT models. Now the open portals or open tools are so strong that you don't need proprietary softwares. So basically you can use Python, Java, and you can create a solution on analytics using all these data sets. So let me give you one example. For let's say you have to monitor a port activity, a shipping activity, and you already know that, okay, I have to track the ship movements in the canals, like the Suez Canal. So there, what you need exactly, you need the satellite data sources in the form of images. You can simply show the images in time scale, and you can create video. Or let's say you don't have that much, it's a data intensive process, so you cannot store that huge data. So what I want to do, I want to create a model that detects the ship, then create that output as a chef file and create multiple such output and show it in a dashboard wherein you tag every ship with unique ID. And then you show the analytics. What is the movement? What is the busiest port? What is the density of the port? Correct? And what are the relaxed time? So that sort of information is what comes under geospatial analytics. It's a combination of multi-source data sets.
And sir, what is remote sensing?
Yeah. So the first part itself, the image that you capture from the space. So remote sensing in layman is something that you can sense from the distance. So it's like a camera, optical sensors. And in terms of right now, we have satellites orbiting around the world, capturing data sets in multiple wavelengths. So wavelength is what's decide the technology in the remote sensing. The optical remote sensing has a different wavelength, operating wavelength range. Hyperspectral is different, LiDAR is different, and SAR is different. And everything comes down between the trade-off between what you want to see, what resolution you want to see. For example, at the moment, uh, the maximum resolution optical image that you can capture from the satellites is 30 centimeter at 4 band or 6 band, correct? RGB, NIR, and then red edge. However, if you want to capture more bands, let's say you want to capture the data for 100 bands or 500 bands, that becomes hyperspectral. And while doing so, you cannot keep the 30 centimeter spatial resolution. You have to do the trade-offs. So what
So
you do
it's
is you include,
just to be clear, 30 centimeters means 30 centimeters per pixel.
yeah, spatial resolution on ground. Yes.
That's a
So
lot of
if
resolution.
you, yeah, so if you increase the spectral resolution, that means number of bands, you have to automatically reduce your spatial resolution. So it will go from 1 meter to 3 meter in that range. So there is a trade-off. You cannot achieve both at the same time. But now recently, the sensor technology is improving, and people are developing indigenous sensors that can capture very high resolution optical image at 10 centimeter from the space. So these technologies are coming up. There are a couple of startups currently working in Canada or around the globes, like Albedo. They are developing such sensor. What is now? Let's see the SAR's perspective. Now, SAR is something which works in microwave range. When I say microwave range, is that it can see through cloud and smoke. So at any moment when optical sensors gets blinded, you can use SAR for the monitoring. So SAR gives you uninterrupted view of the globe despite of clouds and all. However, that is also function of frequency. So at particular threshold, SAR also gets some noise from the rainfall or water clouds. But generally, in the event of disaster, let's say there is a flood or there is a high cloud coverage and there is a flood. Generally, floods are associated with high cloud coverage. Correct. So if you want to see through that layer, then you have to use the SAR.
Okay. So, like SAR is acronym for what? Like, what's the full form?
SAR is synthetic aperture radar,
Okay.
and it works in microwave. So it has a frequency between millimeter to couple of centimeters.
Okay. So basically, it's a radar technology.
It's a radar technology, yes.
Okay. So let's take a quick detour from the technical details behind remote sensing and geospatial analytics, and let's get back to you. So, what initially drew you to the field of remote sensing and geospatial analytics?
Okay. So I started my graduation in electronics and telecommunication. But earlier I had deep fascination with astronomy, astrophysics, or space science. But I got a real chance of working on this domain in my master's, where I started working on ground radar data. So the data was collected from a facility in Gadanki, Tirupati. It's called as MST radars. So it's MST means mesosphere, stratosphere, and troposphere. It generally uh, to be used for ionospheric research. I was given a task on analyzing the meteors or a meteorite, what we call generally in the shooting stars. So in the deep night sky, when you see the star is falling, that is nothing but in layman term, it's shooting star. But when you say scientifically, it is called as meteors. So meteor is nothing but a phenomena where the extraterrestrial body, extraterrestrial object, when interacts to the Earth atmosphere, it creates uh, very high bright returns, optical. If you see in optical images, bright returns like shooting stars, it's called as meteors. And when it survives its journey through the Earth atmosphere, and when finally it lands on the Earth and it creates the crater, now that body which survived is called as meteoroid. So it was more of a sort of fundamental research, but that actually added a lot of curiosity further. And during this phase, I was fortunate to interact with some renowned scientists and facilities in this field. So I would name a few, like IUCA, there is one facility or center, Inter-University Centers for Astronomy and Astrophysics. Then there is a Tata Institute of Fundamental Research. Then there is a NCRA, National Center for Radio Astronomy, which is responsible for maintaining the GMRT facility, Giant Meter Radio Telescope in Pune. And some of the great minds who has actually developed these telescopes and UT radio telescope, or even to get to understand what international facilities are available, like RCBO in Puerto Rico, Mu Radar in Japan, and Icamarca in Peru. So these are very renowned facilities in radar domain that are available globally. And my mentor at in my master's, I would like to mention his name, Dr. Akshay Malhotra, who's a space physicist, actually created this environment around me and gave me opportunity. So wherever it's possible, I could go meet people. I could go into this institute for meetings along with him. And now this experience and the people I met there left a lasting impression and inspired me to explore career in remote sensing, particularly in microwave remote sensing. So after my master's, when I finished my master, I worked for a brief period of time as assistant professor uh, for electronics and telecommunication, where I taught subjects like antenna and wave propagation, digital signal and image processing. So that was around electromagnetics. Then came an opportunity where I joined for a DRDO and DST funded projects in Center of Studies in Resource Engineering at IIT Bombay. And that really opened my door to PhD at IITB Monash Research Academy. So it is a dedicated department at IIT Bombay, which looks after collaborative works between different departments at IIT Bombay and some university, like in this case, it's Monash University, Clayton, Melbourne. And you go there for part of your research, complete the part of research in Australia, and come back and submit your thesis at IIT Bombay. So there I actually then started my deeper understanding on SAR, synthetic aperture radars. Had advanced concept like polarimetric SAR, Polin SAR, INSAR. And these both institutes have given me very meaningful exposure in terms of how diverse the culture is, the complementary skill set between the mentors. And that's how I started my PhD journey.
Okay. So you mentioned that you did your PhD from IIT Bombay. So can you share a bit about your journey through your PhD at IIT Bombay and how it shaped your current research?
Yeah. So I did my PhD at IIT Bombay. It was not a regular departmental program. It was a collaborative or joint PhD program between IIT Bombay and Monash Research Academy. And that period was really transformative, both in terms of technical and personal level. So the program actually begins with a rigorous coursework for a year, where you had to secure some GPAs to continue into your research part. So if you don't qualify for that GPA criteria, and then you basically cannot continue in the PhD program. So this phase is actually very critical, and both in terms of your future journey, but also creating a very strong technical background. In this coursework, you take subjects that are relevant to your thesis. You ask your advisor, mentor for the recommendation. And then what you do is, once you do the coursework successfully, then you have to present the thesis idea in terms of research progress committee. They review the entire idea or goals of your research, and they help you crystallize your thoughts further and align it to the practicality of real world relevance. If let's say you are going to offbit, or the research progress committee thinks that, okay, this cannot be done in 3 years, or this is too ambitious, then they can chop it into pieces, and they will then can create a long-term goal, like, hey, you can take these 3 goals for your PhD, then take these 3 goals for your postdoc, maybe your ongoing research career. After you do this phase, the actual research starts in the second year. In my case, I was working with the cryosphere or snow remote sensing, if you called it as. So my thesis was monitoring snow water equivalent in Indian Himalayas. So in that case, I have to develop algorithms to find out snow depth, snow density, snow water equivalent. And to do that, I have to rely on some SARs, data sets. In my case, I was using X-band SAR, TerraSAR X from Germany, German Space Agency. One of the important part of my research work was field work, because whatever I could calculate from the satellite has to have validated with the ground measurements. And snow is a very dynamic entity. It changes its phases very rapidly. So only period I can go for the field is peak winters in Indian Himalaya. So I stayed there for continuously 3 years in January or February for 1.5 months, under minus 13 degrees, and conducted my field work. And SASE, Snow Avalanche Study Established Facility in Manali, which is counts under DRDO, helped me get there, provide logistics, provide the security, and also conduct the field work. So, so the field work was a bit tough because you have to wake early in the morning at 5:30 in the mountains, and it's minus 13, minus 15 degree freezing. You have to dig a pit of snow and collect the measurements. And it is not just one pit. You have to collect 13, 15, 16 pits. And there was two passes. So satellite was supposed to pass in the early morning, 6 a.m. and the evening or 6 p.m. So in both the time frame, the temperature was very low. So I have to do this field twice a day for those satellite passes. And that was really good experience because it creates the whole picture in your mind. You understand the field, you understand the algorithms, and I was also a part of a couple of field campaign for my colleagues who working in forest biomass. So that is whole the field experience that I would say a highlight of my PhD research. And in third year, I moved to Monash, Melbourne. That is the second part of my research work, and it was really crucial. I focused mostly on algorithm development and writing research papers. Then it was supported graciously by my mentors, who actually uh, gave me a chance to travel. I have received travel grants, equipment supports, go for international conferences. So that part is basically compiling all my creating all the results and then comparing with the ground measurements. Then in 2019, the COVID hit. I had to return back to India, but that was just 6 months before global lockdown. So I was in back in India, but I could not more access the labs at IIT Bombay. So I had to work in isolation. But I used that period to write research papers, finalize my thesis, plan my next career steps. And during this time, I connected with a lot of professionals through online portals. And there I got also some directions from a couple of people. So I would like to mention an individual called as Dr. Daniel Clausen, who is right now working with the Belgian intelligence. But he played a very crucial role on mentoring me towards industry opportunities. Right? He was working with industry from the last 20 years. Eventually, I chose industry over academia and joined US-based startup, where I finally got to apply my academic skill sets, solving real-time problem like wildfire mapping, hazard tree detections, emission monitoring. So this is what a total experience. And right now, I'm working for a company in Japan.
Okay. So, sir, from coming from a student perspective, you said that there is mandatory coursework in PhD for at least the first 2 years, right?
First year,
So
first year.
only first year. Okay.
Yeah.
So like how challenging is it to, meet the required CGPA goals and all that? Because I'm a student who is, planning to do PhD, and I have applied for a few, you know, I have applied for PhD, in for July 2025 session. So before going into that, I would like to, know it from
Hmm.
you. How challenging is it?
And that's a good question because it really depends on what sort of program you are going into. Let's say you are going into a full-time PhD program and from a very prestigious universities, even if it's India or abroad. it is also a function of which department you are going in. What thesis are you thinking of? Correct. And based on that, the subject that are suggested by your mentor can add to the complexity or toughness to the qualification process. But if you have a decent, let's say, if you are going into these prestigious institutes, if you have a basic idea, if you have very basic understanding, you are good at mathematics, you are good at computer science at certain level, correct? Then it is not an issue generally. Mostly everyone who's going for this program have already faced a very strict scrutiny, correct? A very laborious or very intensive admission process itself. So these institutes purposely keep it very tough because once you qualify for that test, then there is no turning back. That means that you have all the basic skill set that will enable you to cross that hurdle of GPA. So it's not that tough, but you have to properly attend classes, labs. If in your case, if you let's say you are working in chemistry domain, then you have to attend the class and labs also. But it is not something that can be taken lightly. If you are sincere enough, you have to provide the entire day for this coursework. Then assignments can be sometimes tough because uh, it has a certain deadline, so they keep it purposely very intensive, correct? But I would say that it's up to you. But what once you have got enrolled into this prestigious institute, I think you are good to go for attending those GPAs.
Okay. So there are two ways to get into PhD, mainly two ways to get into PhD in India. Like one is to clear UGC NET and
Mhm.
first do master's degree and then clear exams like UGC NET and then apply for PhD. And then for BTech students who have a CGPA of around 7 or 8, they can directly apply for PhD after qualifying GATE. So
Yeah.
for a student who has done BTech or in certain engineering domain and then qualified GATE, and then they are applying for PhD, and suppose they get into institute after qualifying GATE, and they start their PhD journey. So do this you know like naturally one would think that students who did their master's degree first, they would have some kind of an advantage over students who are going to PhD directly from BTech. So dif how much of a difference does it make?
I don't see much difference in this scenario, but let me give you some perspective over it. There are some institute or some program where directly a BTech guy can enroll into PhD program, but sometimes it's called as integrated PhD program where first 1.5 year or 2 years is master and then next year is just continuing your master thesis, correct? So there you save some time in completing your PhD. However, I'm not sure, but there are some rules in India if you want to apply for professorship, and if you are directly going from BTech to PhD, you're bypassing masters. I think you are not eligible. I'm not sure, but this is something which I've heard, but you can cross check it once. In industry perspective, in long term research career, it's not a problem. So if you are bright enough to get a very good score in a BTech and you decided that okay, hey, I don't want to check any alternative career path, but I'm very sure that I want to pursue PhD in computer science or in let's say finance or any domain that you are certain of that I will do my career in this domain. There you can directly go for BTech to PhD. But let's say you are not sure, you want to still figure out after my BTech, let's say, let me go for master degree and think before I dedicate my additional 3 to 4 or 5 years in PhD. I want to have some thinking time. There you can use the masters to your advantage.
Okay. Sir, coming back to your work, your work involves electromagnetic theory and microwave remote sensing. So, can you explain how these are areas contribute to practical remote sensing applications?
Okay. So let me explain exactly what microwaves are so that you can imagine the use cases around it. So microwaves treated as the invisible flashlights that satellite carry, but unlike the optical or light source, it can see through clouds, smoke, or even total darkness without the sun. This makes microwave remote sensing incredibly valuable tool, especially when optical sensors are blind. So the microwave operates in few millimeters to centimeters region. So these signals are transmitted from the spaceborne or airborne sensors, like synthetic aperture radars. And when I say it is active remote sensing, that means you generate microwaves on board. You send it and then you receive it. The optical remote sensing is passive remote sensing, where you don't generate the light. It is basically light source is sun. You just receiving the scattered or reflected waves back. So you have complete control over the source or waves that you're sending in active remote sensing. That is what SAR is. These wavelengths, these waves are then interact with the Earth's surface, bounces back to the sensor. We call it as a backscattering. Now, this backscattering depends on physical and dielectric properties of the target. So whether it's snow, whether it's a vegetation, whether it's a soil, water, or even man-made structure like building and roads. So it carries certain information in the backscattered signal. This is what simple SAR works. Now, if we go a step further into polarimetric SAR, here in this case, we are not just looking at energy that is reflected back, but how its orientation changes, how the wave's orientation changes. This gives a very rich insight about a structure and material composition of the target. It's like coming from a black and white domain to full HD domain, color domain, when trying to understand the surfaces. So if you want to get into the practical applications, the one application that I already told you about, snow parameter retrievals or snow or crash for remote sensing. So in this case, the motivation is to find out the snow water equivalent. Now, what is the snow water equivalent? So it's nothing but the amount of water snowpack can produce when it is melted instantaneously. So let's say a block of 1 meter by 1 meter cube of snow, when it melts, it attains certain height in that box. That is nothing but snow water equivalent. Now, how it can be used for practical applications? When you have a peak winters and when the snow is in solid form, it's not melting. In the summer, you have to have an idea what is the outflow from that snowpack when it gets melted, because you have built a lot of dams on the river streams. You have to manage how much water I should expect, and I should operate the gates accordingly, because that is how the needs of all the people can be served. Along with that, the hydropower dams. If you understand, if you know that, okay, I'm expecting X amount of water in this summer, you can do your planning wisely, and you can also avoid some potential disasters, correct? Due to the dam breakage and everything. So that is what you can really, in hydrology, basically, you can work in this. This is what the use case of my research. When you go for, let's say, tree or forestry monitoring, now you can use multi-source information and map the trees, correct, along the corridor. So I will give you the example from my previous company. So we were into the utility management. Now, what is utility management is that you have to manage the linear assets like transmission line and distribution lines, power lines. So there is a mandatory rule of maintaining right of ways, which is 300 feet or 200 feet corridor along the center line, correct? So there you have to detect trees and give analytics on whether that tree is hazard, or if it falls on the transmission line, can it create outages. So when these power lines go into the vast forest land, and when forest is dry, and if there is some sparking happening, that could lead to wildfire, correct, which is uncontrollable. So the utility companies gets heavily fined for if it got to know that the source of ignition is from their power line. To avoid that, this utility company goes for intelligent solutions that involves data science, remote sensing, and that is one of the use case. Similarly, you can translate this use case to wildfire risk mapping. You can map the dried up biomass in the forest, and you can then plan accordingly. Correct? There is a, let's say there is a fire already started, and you know that okay, all the area around this point is dry. So basically, it is difficult to control, but you know the barriers where you can control it. River stream, or let's say lush forest or green forest. There you can just put some fire retardants from the helicopters, and then you can stop. Similarly, wetland and peatland condition assessment, where you can uh, use the surface roughness of and water content, detecting the changes in wetland boundaries, degradation in peatland. So there are numerous use cases. Also, a separate sector in defense. SAR is used predominantly towards maritime monitoring, port monitoring, or border monitoring, or whenever you want to see certain activities in warfare. So that is where you can use this use case. And even outside whatever I've dealt with in the past, urban infrastructure monitoring, agriculture decision making, disaster management, these are a couple of practical use cases that you can think of.